Okay, now let's do this Van Air binomial example in Excel. So this overbooking example. Okay, so there were 18 seats on our flight. Let's start by allowing for 22 reservations. We're going to start N at 22, and we can change this later. Odds of each person showing up is 90%. Little note here for binomial distributions. We call the N the number of trials. Let's have a look here. So it's that number of trials. That's the total number of people who can show up. So these are the people we're kind of rolling the dice on. So we allow these 22 reservations, up to 22 people reserve. If they do, then they might or might not show up. Each one has a 90% chance of showing up. And X is going to be our number of people who actually show up. Okay. Now before we jump into that, let's look at an expected value. Let's look at how many people we would expect to show up if we allow for 22 reservations. So for the binomial distribution, the expected value, which is also our average or our mu, it's just N times P. So just take your N here. Be so careful, that's your 22 times P. Okay, don't be distracted by your number of seats. Your seats do not show up. They are just there, right? We don't do any odds on the seats. Let's hope they're all bolted to the floor and they stay where they are. Here they all are. There are always 18 seats. What might or might not show up is the people. Maybe there'll be enough to all fit in the plane, or maybe there'll be extra people. We don't know. Every day can be different. Okay. And, oh, so sorry. Beautiful. So our expected value is 19.8. Okay, so back to our graph here. That's roughly 20 people. You'll notice that the bar is very high right there. Our odds of exactly 20 people showing up is pretty likely. So again, we're going to want to re-examine how many reservations we allow for. We'll play with that later. So right now we expect 20 people to show up. That's too many. We only have room for 18. Now, what are the odds that the plane is exactly 100% full? So what are the odds that just exactly 18 people show up? That's what we first looked at in the PowerPoint here. So we just use the binom.dist. Put in the 18 for our X. These are our number of successes. Put in 22 for N, 90 for P, 0.9, and put cumulative to 0. When we want the odds of exactly one number for the binomial distribution, put a 0 for cumulative. Okay, so roughly 10% chance of exactly 18 people showing up. Okay, we want that higher. That's our optimal. We want the plane at capacity without being overbooked. Now, the next question we want to answer is, what are the odds of the flight being overbooked? And that's this scenario here where over 18 people show up. If we allow up to 22 reservations, that's either 19, 20, 21, or 22 people who show up. Now, a little bit easier than doing this calculation, let's look at kind of the opposite of that first. Let's look at the odds of there being enough seats for everyone. Okay, so that's this yellow area here. So 18 and below. If up to 18 people show up, we have enough seats for everyone. If you'd like to, you can look at this in Excel too by doing a little chart here. I like to do these charts for the overbooking examples. So if I'm looking at having enough seats, I do a little kind of table here with the number of people who show up versus the number of seats left. So if nobody shows up, there's 18 seats left. If all 18 people show up, then there's no seats left. They're all full. If 19 people show up to 22, well, we're out of luck. These are our number of overbookings here. Okay, so if anywhere up to 18 people show up, we have room for them all. And it could be any scenario, anywhere from nobody showing up to all the way up to the 18. So we want to look at the odds of X being less than or equal to 18. So this shaded area right here. Okay, so to get that in Excel, you just do a binom.dist and put in the 18. If we want less than or equal to 18, put in the 18 for our X value. And again, is 22. The odds of success or showing up is 0.9, and then put a 1 for yes. If we want this entire area up to and including the 18 right here, put cumulative to 1. Okay, so the odds of there being enough seats for everyone. Whew, only 17%. That is not very good. So what comes quite easily from that, after doing that, is the odds of the plane being overbooked. So if there are enough seats for everyone, that's a 17% chance. That means if we take 1 minus that amount, it gives us the odds of being overbooked, which are 82.8%. So 82% chance we have too many people. So it's this red shaded area here. So what I love is that now that you've got everything set up, you can just play with our reservation limit. You can just play with that 22. See what happens when you put it at 21. Okay, now we're down to 64% chance of being overbooked. That's still way too high. Let's try 20. Now we're down to 39% chance. Let's try 19. Now we're down to only a 13% chance. So maybe we're going to allow for 1 extra person on this flight. That's still pretty high odds though. Only 86% chance there's enough seats for everyone. So maybe for these small flights, the airline can't afford to overbook. Because even up to 19, so even up to just 1 overbooking here or 1 extra allowable reservation than the number of seats, puts us at a 13.5% chance there's not going to be enough seats for everyone. That's pretty high. That person will be very unhappy, whoever they are. That's pretty high odds of having somebody who's very unhappy out of your 19 people total for the flight.